What is parallel plate capacitor? Obtain the formula for capacitance of such a parallel plate capacitor and on which factors does the value of capacitor depends. Arrangement of the two large plain parallel conducting plates separated by a small distance is known as parallel plate capacitor. Non-conducting medium is kept between the two plates of such capacitor. Free space will be taken as non-conducting medium. You can see in figure also. The plate 1 and 2 cross section area capital A, the separation is small d, and the field is shown here from plus to negative. Surface charge density plus sigma and surface charge density minus sigma for negative charge. According to figure, the charge on plate 1 and plate 2 are capital Q and minus capital Q respectively, and small d is the separation between them, and capital A is the area of each plate. D is much smaller than the linear dimension of the plate, therefore d square less than A. So we can use the result on electric field E is equal to sigma upon 2 epsilon 0 by an infinite plane sheet of uniform surface charge density, where sigma is equal to surface charge density and plus minus sigma is equal to q upon A. Epsilon 0 is a permittivity of free space, capital A is equal to area of plate, and capital Q is equal to charge on plate, capital A is equal to area of plate, and capital Q is charge on plate. The region above the plate 1 E is equal to sigma upon 2 epsilon 0 minus sigma upon 2 epsilon 0, therefore E is equal to 0, equation 1. Region between the plate 2 E is equal to sigma upon 2 epsilon 0 minus sigma upon 2 epsilon 0 is equal to 0, E is equal to 0. Number 2, the electric field between the plate 1 and 2 E is equal to sigma upon 2 epsilon 0 plus sigma upon 2 epsilon 0 is equal to sigma upon epsilon 0, where sigma is equal to q upon A, therefore E is equal to q upon epsilon 0 A, equation number 3. E is equal to q upon epsilon 0 A, equation number 3. The direction of the electric field is from the positive to negative plate. The electric field is localized between the two plates, but the field lines bend outward at the edges, an effect called fringing of the field. Hence, E is equal to q upon epsilon 0 A will not be uniform on the entire plate. However, for d square less than A, these effect can be ignored in the region far from the edges. For uniform electric field, V is equal to capital E into small d, therefore V is equal to q d upon epsilon 0 A. Now capacitance of the parallel plate capacitor C is equal to q upon V is equal to q upon q d upon epsilon 0 A, therefore C is equal to epsilon 0 capital A upon small d is the capacitance of the capacitor. Capacitance of parallel plate capacitor depends on the following factors. First area of plate, and that is C is proportional to A, and separation between two plates, that is C proportional to 1 upon D, and third, permittivity of the medium between the two plates, C is proportional to epsilon.